So we're gonna make another controller that moves the cube with our mouse. Okay, so I'm gonna just clean up some things here, and I'm gonna make a new script, call it mouse controller. And the mouse controller, I'm gonna go ahead and open it up. The mouse controller, okay, is going to take a public target this time. So it'll be a transform, and it's gonna be a target. Okay, and then we're not going to need start for this, so I will just delete that. And then in update, we need to get the mouse position of our mouse. Get the position of our mouse, and then translate mouse position to world space, and then set object position in world space to the mouse position in world space. So, I've got this diagram of some of our different coordinates, okay? Of our different coordinate systems. And we have a couple different ones, alright? We have world space, which gives us our X, Y, and Z. We have screen space, which only gives us an X and a Y, but it gives it between the resolution of our screen. So I have a 1080p monitor, so it's 1920 by 1080. And if I had my mouse in the middle of the screen, its screen position is 960 by 540, which is the screen position divided by 2. We also have viewport space, which is like screen space, but it's in the perspective of a camera in one of our viewports. So instead of being between 0 and the resolution of our screen, it's between 0 and 1. So if my mouse was in the middle of the screen, it would be at 0.5, 0.5. So Unity lets me easily translate between these. But first, to just get my mouse position, okay, I'm going to say vector3 mp for mouse position is going to be input.mouse position. Now, this next little bit here is a little tricky, and this is not ordinarily how you're going to move things with the mouse, but I just wanted to illustrate how we get the mouse position input. In order to translate our screen space into world space with the camera, we need to say what Z coordinate to do that on. Otherwise, it's going to think, place this right on the camera, which is not what we want it to do. So I'm going to say the Z of my mouse position, even though it doesn't exist, right? Even though there is no Z for my mouse, I'm going to say it's going to be the position of my camera, okay? And I'm going to add just some units to it, okay? Just put it in front of my camera. Sorry, .z. So what did I do here? Okay, camera.main. I'm going to use this again in a second. This is just a quick way to access our main camera. And then I'm accessing that camera's transform component, and then the position of that transform component, and specifically the z of the position component. Then I'm adding 30 to that value, and setting that to the z coordinate of my mouse position. And now this will make this next line make a lot more sense. So now, the world space of my mouse, okay, is going to be camera.main once more, and I'm going to say screen to world point, okay? And so the reason I had to set the Z was so that the world point I make is on a certain Z-axis. Otherwise, it defaults to the axis of the camera that's doing the transformation. So our object would be drawn behind us, which is not what we want. And so I'm going to give it the mouse position. And now I'm going to set target.position to world space. Okay, so now I'm going to go back to Unity. I'm going to drag my mouse controller onto here. And so because I used a public transform this time, and I didn't use start to assign the transform, I need to assign transform through the inspector. So I can drag transform right into here. And I can also use the circle here and select my cube that way. This was like what we did with speed, though now it's with an actual component. Now if I hit play, look at that. The mouse, or the cube rather, is following my mouse. So this is not the best way to get mouse input. We could use ray casting to do this. We could cast a ray from the mouse point into the world, and that would ordinarily be the way you do it. So if you're going to make a real-time strategy, you should be using ray casts. And we're going to talk about ray casts later, but for collisions, not for mouse. They are actually very similar topics, though. So for now, I'm going to delete my mouse controller off my cube and go back to my WASD controller with the player controller. Let's make sure that works. And there we go. Alright, so it's real slow. I think I had it at 10. So, alright, so that covers gathering our inputs and a couple other things like that. So, we've talked about normalized values, and I did want to mention this really briefly again. Okay, so I'm going to go back to Photoshop, and I forget what layer I had it on. Okay, so the idea of having a normalized value, okay, and it can be from -1 to 1, or it could be between 0 and 1, okay? We can do so many things just by having this number, okay? A whole timeline can be represented by this, right? Just think, these are percentages, right? So we have 0% to 100%. And you notice that in these examples with the scripting, I've been moving things one frame at a time, okay? And then calculating stuff based off of where it lands. If I want to be specific, I can move a spot. How would I go from A to B, okay, in T seconds, okay? So if you're an animator, right, you will make a tween, is what it's called. And you say, we're going to go from A to B, we're going to give it some animation curve, and then we're going to say, go from A to B, use this curve and do it in T seconds. You can do that in Unity, and we're going to talk about that next week. But while we do input now and controls now, we're doing things a frame at a time. We don't have to do it that way. So when we revisit this in the future, keep that in mind. So next we're going to talk about instantiation, okay? Instantiation is what lets us spawn things in the world, okay? And I am going to borrow the same code from the mouse at one point to do this, so we will be reusing some of it. But first, let's start with the basics. We want to spawn this cube at runtime. Okay, the same cube that we're going to control. And there's a couple ways we could do this. But the first thing we need to do is we need to turn our cube into a prefab. You can instantiate prefabs or game objects at runtime. Instantiation just means, let's make a copy of this, okay? And you can make a copy of a game object, you can make a copy of an asset. The reason you do it with prefabs is because those are assets, and that means we can store them, okay? So say I like the fact that this moves at speed 10. I will save this as a prefab. Okay, now I have this cube with a speed 10 as my prefab, and you can see it's blue here. Now I'll delete this, okay? Now I don't have a controller. What's happening? Nothing. Alright, so I'm going to make a script, and we will call this cube spawner. Okay, and I will drag this onto, sorry, not my camera. I'm going to make a new empty game object, okay? And I will call this spawner. And I will attach the cube spawner to it. Move that back in the scripts. Alright, now I'm going to open this up. Like we did with the transform, we can link assets with scripts. Okay, we can link prefabs. And the way I'll do this is I'm going to make a public game object, okay? And I'm going to call this, the cube prefab, okay? It's important that you don't modify the properties of prefabs from your scripts. Now, I say that, you can do it, and if you know what you're doing, it's very powerful. But for now, don't do that. It's probably more trouble than it's worth. Because what that would do is that would change the asset in your project, which you probably don't want to do at this stage in the game, because you just want a copy of it. Okay, so we want, in this script, we want to, when we hit play, spawn our prefab at 0, 0, 0. Okay? And that's actually really simple to do. All we need to do is say instantiate. And if we are a mono behavior, we have access to this method. Okay? And we just say instantiate, and I'm going to give it an object. I'm going to give it the cube prefab, and I'm going to say do it at vector3.0, and I need to give it an initial rotation. I'm going to say quaternion.identity. This is just a shortcut for saying don't give it the rotation it already has in the prefab, and then that's it. So if I go back here, spawner. Did I... Oh, I forgot to save. Be sure to save. Okay. Alright, okay, there we go. Now it pops up. You see, I can drag in my game object. And look at that. Cube is right there. So now, if I hit play... Alright, I get the cube at 0, 0, 0. Now, functionally, this doesn't feel any different than just having it in the scene. So, instead of spawning this prefab, I'm going to spawn something else. Okay? I could spawn any prefab. Let's make a 3D sphere, okay? And we'll set this to 0, 0, 0. We'll look at it. Let's just make it a physics object so that we can see something happen. And I'm going to make this a rigid body. I'll call it phys-sphere. Okay, for physics, I suppose. And then in my spawner, instead of spawning the cube, I could give this any prefab. So I will give it the sphere. And now, we shouldn't call this cube prefab, but now look at that, it falls. So I'm spawning things. I'm instantiating things. Okay, spawn and instantiate are used interchangeably, though from a design perspective they are different terms, right? Instantiate is actually cloning, okay? It's cloning that prefab I gave it. That is slightly important. I could start cloning objects that already exist, which is a less common use case, but it is something you could do. You could get a reference to an existing game object and make a copy of it. Okay, so I do want to mention, it is worth mentioning, instantiate is an expensive operation. Instantiate has some baggage with it, okay, in that it creates garbage. And so, in programming terms, garbage is sort of an artifact, okay? When you're creating and destroying things in memory, so to speak, stuff that no longer is being referenced by anything, it gets garbage collected. And garbage collection is expensive. So, instantiate will result in some garbage that needs to get collected, which can slow down your game. So if you're doing lots of instantiate calls per frame, so let's do that. Let me show you what happens. Okay, I'm going to just move my instantiate call, and now every frame I'm going to instantiate this prefab at 0, 0, 0. Now, it's possible this crashes Unity. I certainly hope not. Oop. Did I not save? Okay. There we go. Look at that. This is terrible. So I've got a pretty strong computer, but I can hit the stats panel up here, and we can start seeing things happen. My FPS is listed here, and it should, in theory, go down after a while. Yeah, you can see it's starting to get a little slower and slower and slower. So instantiating spawns new game objects, and look at what's happening in the scene here. Look at it, I've got so many things. And remember what I talked about, how instantiation is cloning? Let me pause this before I do kill my computer. See, instantiate makes the object, but it calls it clone. Let's see what's happening here. This is cool, kind of like fractal art, though. I like it. And the reason these are exploding outright is that these rigid bodies are on top of each other, and it's physics figuring out what it's supposed to be doing. And, you know, we could take this... We could get really extreme with this. We know these are spawning at 0, 0, 0. Let me make some walls, okay? 0, 0, 0. Let's move it over here. And this is really cheeky, but I just like watching physics objects collide with each other. So I'm going to do this anyway. Doesn't need to be exact, because we're going to break it. Okay, now I hit play. Yeah! Woo! That looks really cool, actually. It's kind of like a really basic fluid simulation. But look at that. My frame rate died so fast. I had so many physics objects happening all at once, and that just kills performance. So, in general, you probably can't do much with Instantiate right now. That'll break your game. But it is a common reason why performance starts to lag. And we'll talk about optimization more later, but this is a common spot for optimization. So, instead of spawning it at 0, 0, 0, what if we want to spawn it at another location? And I'm going to go ahead and rename my cube prefab. I'm going to do something called refactor. And the shortcut is Control-R in Visual Studio, and I believe it's Command-R on MonoDevelop on a Mac. So I type this, and I'm just going to say prefab to spawn. Okay? And instead of spawning it at 0, 0, 0, I want to spawn it at a specific location. And I can do this a couple different ways. First, I can make a vector 3. Okay? Then I could say location. And then I replace vector 3.0 with location. Now if I go back to my spawner, go here, sphere. I'm not sure what keeps happening here, but my Visual Studio seems to fail to save every once in a while. Okay, there you go. You see, and now I could set the location. So it's still 0, 0, 0, right? But let's move it 5 units to the right. Now I should see it over to the right a little. Yep. Okay. So that's changing it one way. And again, making these public variables and exposing them to the inspector allows designers to really just focus on parameterization and changing the way things feel. So when we were looking at the character controllers last week, that's what they were. They were public variables that were exposed. So, but I don't want to use a vector 3. That's really kind of lame. Instead, I'm going to use a transform. And now I can give it an invisible point in space. And now I'm going to refactor this, call it point, spawn point. And here, since this is a transform, not a vector, I just need to say spawn point dot position. Okay, so now if I go back, I can make a new empty game object, and I'm going to go ahead and make this visible here, and we'll call this spawn point. And I'll set this close to 0, 0, 0. I'll set it to 2 and 5, and oh, looks like I have some errors here. What are you yelling at me for, Unity? Okay, again, didn't save my script. Hopefully that doesn't happen to you guys. I don't. That's something new that I haven't experienced very often before. But now, oh, see, so I made a mistake. I forgot to assign my transform. Okay. And that's exactly what happened. I got an error in the console that says the variable spawn point has not been assigned. When I was learning Unity, I had errors like this all the time. And what it usually means is that you've forgotten to link something through the inspector. The error says that much, and yet when I was learning, I still never quite understood what that meant. It is called linking through the inspector when you drag and drop things into these slots. Okay, so I want to say the target transform is the spawn point. So I drag it there, and now that links it. I have linked it through the inspector, and now it's spawning wherever I move this to. Okay. Cool. So, you know, if you were making a first-person shooter, you could start defining your spawn points this way, and that's a really powerful thing to do. Using these empty spawn points to spawn things at is something you want to do all the time. Okay. So, we could randomize this even more, though. What if instead of spawning it at this point, what if we wanted to spawn it inside another object? Now, this is a little goofy, but it's totally something we can do. So, I will I'm going to make a couple changes first, okay? First, I want to spawn this object. Let's spawn something every couple of seconds, okay? Just so that we can see this and make it a little fancier, alright? So the way we do stuff over time, okay, we have access to time elements inside our update. We already used one. We used delta time, okay? We also have timers, like time since the scene started. Now, this is not the best way to do time-sensitive things. We will talk about coroutines next week, and that's usually the preferred way to do time-sensitive stuff, but you can do it in update as well. And we're going to say, float, we're going to make something called spawn time, okay? This will be the time between spawns, and we'll say 3 seconds, okay? And to facilitate this, we're going to need to make a couple of extra variables. So public, this means we can change it in the inspector, so we can play with it after. And then I just need a spawn timer, and I'm going to set this to 0f, and this is, I'm going to increment this by delta time, okay, every frame. So I'm going to say in update, spawn timer plus equal, this is just a shortcut to add a value and set it to itself. I'm going to say plus equal time.delta time. Okay, and then I'm going to say if spawn timer is greater than spawn time, okay, I want to spawn the object. And so I've already written this once. I shouldn't rewrite it again. So I'm going to make a function, and I'm going to call it spawn. Okay? And here is where I'm going to put the spawn code now. So I'm going to replace my call at the start with spawn, and I am going to put spawn here. Now, I also, when this happens, I need to say spawn timer equals 0 again. This way, I don't start doing it every frame. And so now, let's see. Let's just hit play, and every 3 seconds we should see sphere spawn back. There you go. So, again, I mentioned you don't want to do a ton every frame of instantiations, so one every few frames rather will probably be okay. But in theory, eventually we'll have spawned so many game objects that will crash. Okay, so this will help us see things a little clearer. And just to give us a little bit more pizzazz, I'm going to go ahead and make a plane and put that at 0, 0, 0. Move it down a few units so that our spheres land on something. I should move the plane down a little bit more. Oop. Okay, so there we go. This is a little bizarre. Since the object's spawning inside another rigid body, the physics simulation sort of really doesn't quite know what to do. Though this does look interesting. I would be interested to see someone make a game out of this interaction. Anyway, so instead of giving a point, we want to give it a volume. Okay, so this is a concept that's more common in other game engines, not so much Unity. But the idea of a volume is just something that we want to get a point inside this volume. We want to define boxes, things like that. And so I'm going to do that by making a cube. Okay? And this cube, I'm going to set to 0, 0, 0. And I'm going to call this one spawn area. And I'm going to scale this up to sort of cover our plane. Okay? And I am going to turn the renderer off, and I'm going to remove the collider. Or I'll keep the collider there, but I'm going to set it to a trigger. A trigger just means that it won't cause physics collisions. We can use triggers for invisible collisions, like when we pass through a threshold. And we can also use that for volumes. But I'm going to keep the collider turned on as a trigger so that I can see the extents of my box. I'm not going to use the trigger for anything right now. Okay, so in order to get the extents, in order to get the area that this is, I need to get the extents of the mesh. Okay, and the way I do that is I need to get the I need to get a reference, okay, to my volume, and I'm going to say public mesh the target volume, or we'll say spawn volume, okay? Spawn volume mesh. Okay, so now I can get the extents, and the extents are going to be half of the width and half of the height of the object, okay? And then I can figure out the volume to spawn things in, and pick random X, Y, and Z locations based off of that, okay? So, I have the mesh, okay? And if I go spawn volume.mesh.extents, whoop, did I pick the wrong component? So let me double check here in the docs. And I'm gonna say, I should have already had this up. Bounds. Okay. Oh, yep, that's right. Okay. Spawn volume mesh dot bounds. Okay, there we go. So first I have to get the bounds and then the extents. Okay, and this will give me the width, height, and depth divided by 2. So I'm going to say vector3 extents. Okay. Sorry, that's not a function. Okay. And now I'm going to make a spawn location, okay? And I'm actually going to set this to the location of the spawn volume mesh. Oop. Alright, well, I also, okay, so to do this, I also need to get a reference to the transform of the spawn volume. Spawn volume transform, okay? I'm going to go ahead and remove spawn point, because I'm not going to be using a spawn point anymore. Alright, and for now, I'm going to change this to spawn location, and I will change this to spawn volume transform dot position. Okay. So currently, this should act fundamentally the same. I'm going to remove the spawn point, and I'm going to add the spawn area here, and hue. What's going on? Oh, I'm sorry. I needed to do mesh renderer. Okay, and this should still... Okay, and actually, now that I have the mesh renderer, I should be able to do spawn volume transform, or spawn volume mesh dot game object dot transform dot position. And since the mesh renderer is a component, it automatically can access the transform. So I'm going to go ahead and delete this guy, because I won't need to use it anymore. And now if I go back here, let it all recompile. There we go. Okay, so the reason I need the location is so that I can add its extents to it. So right now, since I'm just using the location, I should see the sphere spawn in the middle of my volume every time. But I want to randomize it between its extents. Okay, so I'm going to say spawn location.x. I'm going to modify it a little bit. Since I know this is perfectly in the middle of the sphere, all I need to do is add to it, okay, a random number. So random number generation is pretty easy in Unity. They've given us this simple thing for random range, and I can give it a value of integers or floats from min to max. And I know my minimum is going to be the width, is the x extent, okay? Is going to be the negative x extents, negative extents.x to positive extents.x. I'm just doing the x-axis, so now my cube should spawn on different random x locations in my invisible sphere. My invisible cube. So these volumes will only work with cubes. Extents gives you a box, okay? Not a like a sphere would still give you a box. And so, yeah, so now it's going like this. But I also want to do it for my y and z. Spawn location.y plus equal. I'm just going to copy and paste these twice. Change these to y's and change these to z's. Okay. Oh. And hit play. And so yeah, so now it's randomizing it all about. There we go. So that's how we can set up basic volumes, okay? And this is not a common thing I see done in Unity a lot, but in the spirit of talking about game development as a whole, this is a pretty common thing I see that you could do in Unity pretty easily. This is not a lot of code. Those are volumes that we can use for instantiation, and we saw how to do randomization. Okay, and we can extend randomization. So let me make a prefabs folder here, and I'm going to call this prefabs, and I'm going to rename my cube to controller for now, okay, or character, okay? And I'm going to go ahead and make some other 3D objects. Let's make a capsule. Let's make it a rigid body. Let's save that as a prefab. Game object, 3D objects, and let's do a cube. Rigid body. Okay. And let's do lists in our scripts, okay? So we've already shown how we can link single objects, but we can also do lists and arrays. Okay, so if you've ever used more popular programming languages, well, popular is not the right word, but if you've used a programming language, you've probably used a list and an array. So an array in C#, okay, is simple. We just add in these brackets. So instead of prefab to spawn, I'm going to say prefabs to spawn. And then in spawn, I'm going to pick a single prefab. And I'm going to say, do it from random.range of 0 to the length of that array. Okay? And close that off. So random.range, by the way, if you're using floats, the upper limit is inclusive, and when you're doing it with integers is exclusive. So this will be 0 safe for an array. Prefabs to spawn. Okay. Whoop. Okay. So now if I go here, I go back to my spawner. You see, now instead of being able to drag in one thing, I have a list. And I made 3 different prefabs. And now I can drag in 3 different things. Now, that's one way to do it. It's also, I can also just drag and drop one, and it automatically makes the list longer. Okay? So that's one way to do it. I could set this back to 0. I could then select these all at once and drag them on. But in order to do that, I actually need to first lock the inspector. When you lock the inspector, this is a cool, useful editor feature. It's this little lock symbol. Now when I click on other things, it doesn't happen. The main reason to do this is to do what I'm going to do here, which is select all of these at once and drag them in, and then it automatically populates the collection. Now it's super useful. Now if I hit play, you'll see that it's picking different prefabs and spawning them. So this is, if you were making a game that had collectibles that spawn in random locations, this is a good way to pick random locations. And they don't have to be rigid bodies, but this is just a easy way to show what's happening. Okay. So, now that we have this link to spawn time, by the way, we forgot to play with this. I can also change this. I could change this to 0.2. See, look, things are happening a lot faster. And I could go all the way up to 34 seconds. And just being able to edit these values is really powerful. And understanding, being able to just read scripts and understand what these parameters are doing is essential to being a Unity developer. So, and you know, you can just see, just with basic scripts like this, we can actually make some pretty weird things. I could totally see games where I'd need to make a pile of stuff. So, something I also want to show you guys is, let's take that character, okay? We've talked about physics before. Our character is being moved, alright, and it has a collider. It is not a rigid body. And I'm going to set our cube off to the left. Sorry, right? I'm going to set him over here. And let me just set this to 0.5 again. Let's go real fast. I just want to get a bunch of objects here. Okay. 0.5. Alright. If I start moving my cube through, you can see it is pushing stuff away. And this is totally fine, okay? Physics objects and non-physics objects do interact in Unity, okay? I am pushing things out of the way with this collider. But since it's not a rigid body, it's not quite using a physics simulation. And this is why we had the rigid body first-person controller and the non-rigid body first-person controller. Okay, so in some instances, this will not be what we expect. And so what I want to do now is I'm going to turn off my spawner. Okay, I'm just going to disable this. We'll still get one object that spawns. Sorry, we will not get any objects that spawn. I'm going to bring it back later, but I want to edit this guy to use physics instead. And so in order to do this, I'm going to zero my character, okay? There's a couple things. First, I'm going to add a rigid body. Let's see what happens. If I make this a physics object and it has my control, what's going on? You can see that things are sort of fighting. Okay, and that's because gravity is getting really great as I go up, right? This push down is still happening. Gravity's still happening. Now, there's no forces that's moving me left and right, but just up and down. And you can see this makes a really twitchy controller, right? It kind of looks like I'm jumping, but I'm really not, right? It's similar to jumping, but it's not quite the same. And look at that. You can see physics and regular objects interacting gets wacky after a while. And this is because I'm trying to move it down, but physics is saying, don't. The whole collision system is saying, I really shouldn't be able to move down right now, but you're moving me halfway. You're moving me a couple of units, and then the collider is halfway. So what if I set the speed to, like, 2,000, okay? Look at that. It just went right through it. And the reason that happens, okay, is because physics would know to check if I'm about to move through a solid surface. But just translating the position, it does not. So there's a couple ways. There are better ways for us to move our object with physics, okay? And it's really popular to do in Unity, and let's see how we do that. So we've made the rigid body, okay? And I want to get a reference to the rigid body in our player controller. Okay, I'm going to close this. And I could do that by making a public thing like we've been doing and dragging it in. But I don't want to do that. I don't like linking things through the inspector. It gets exhausting moving my hand around that often. So instead, I'm going to say private rigid body, and I'm going to call this rigid body. By the way, if you are scripting, you will notice that sometimes you get this option, okay? Get the rigid body attached. This is deprecated. This was going to get removed in a future Unity version, and you should avoid it and not use it, okay? It used to be you'd have automatic references, but those calls used to be expensive. Kind of like how Instantiate had hidden baggage, those would have hidden baggage. So you'll see that, and you'll see code that still uses it. And you just need to recognize that that's out of date. They shouldn't do that anymore. You need to set up your own references to your own rigid bodies. I'm going to say rigid body is equal to this dot get component. And I'm going to say get the rigid body component. Okay, and what this is going to do is it's going to find the rigid body and it's going to set it. And this get component is similar to instantiate, and then it has some extra baggage that slows things down. You can imagine that it's looking through every component on the object and returning the one when it finally matches. And it does some like low-level comparisons, and it doesn't affect things logically. It just under the hood it can affect things as time goes on. So when do you think we'd start hitting problems with physics and regular objects, okay? Translating things. Like, so this is happening in update, right? In order to have a perfect physics simulation, or something even resembling a perfect physics simulation, we need to have physics running at a constant time step. And update isn't constant, right? Update is happening at the speed your computer's running at. It's happening at your frame rate. And because of this difference, we don't do physics-based calculations inside update. Instead, we do it in a fixed time step, something called fixed update. And this is another callback. So if I make a function called void fixed update, okay, and then I say print fixed update in here, okay, I go back and hit play, we'll see a print statement, but we won't see it every frame. Instead, we're going to see one, I believe it's every 50th of a frame is the default value. But we can actually check what this is. So if we go up to edit, it's a project setting. Eject project settings, then physics. No, maybe it's not in here. Okay, so, well, we can change gravity, by the way. There are lots of physics settings we can change, right? Gravity is approximately 9.81 meters per second. Oh, where is it? Oh, mish. You don't very often change this, okay? Changing it can affect the performance of your game, but the physics time step is in here somewhere. Quality, maybe? Oh, where'd it go? Whew. Alright, well, it's not super important, but it does exist, and you can change it. But I do believe it's every 50th of a second physics gets simulated. Okay, so in fixed update, this is where we want to do our physics-related calculations. Okay, and there are a couple ways we can do this. The main method to do it, right, you still need to capture input. You want to do input every frame, okay? But you don't want to do physics calculations every frame. You really only want to do it when you capture the input. So you want to get your input in update, and then when that input is held, you want to do something in fixed update. So what we're going to do is we're going to ignore fixed update at first, okay? And you know what? In fact, I'm probably just going to ignore it today in general. You want to do physics-based stuff in fixed update, but in the interest of time, we're just going to do it inside update for now. Okay, so we've already grabbed our input in update in this script, and we're saying offset.x, and then we're moving it based on that offset. Now, instead, what we could do is we could set the velocity of the rigid body, or we could add a force. So, let's start with adding forces. Adding forces is the main way we do things, or the main physics method of like pushing things. It's equivalent to a push. Okay, so we still want to calculate our offset, okay? And instead, our speed will act as our power and our force for the time being, okay? So I'm going to say, we've already grabbed this rigid body, okay? We're going to say rigid body, add a force. And the force, okay, Um, a vector, alright, let's go back to Photoshop here for a second. A vector, okay, a vector 3 is 3 components, right? It's x, y, z, okay? And a vector 3 is used to represent a position in space, most commonly in Unity. But if you go back to math, a vector is actually a direction, okay? A vector is a direction, all right? It's an arrow usually, right? You go from 0, 0 to that point, okay? And then a vector itself it's got magnitude, right? And it's got a unit vector that is the direction, right? So it's going to be, so if we have a vector v, right, it's actually the unit vector of v times the magnitude of v is what v is equal to. And these are things we can use in Unity. So when we're adding a force, right, we are adding a force in a direction. So if we have a sphere, right, and we want to push it this way, right, we're going to give it a vector to do that, and that will be some vector with some magnitude. So it will be power, right, times direction. And we already have the direction in our script. It's the h and v, right? That's the x and y component of the vector. And then the power is the speed, okay? And so I'm going to do this calculation here, okay? And now I'm going to say it's offset times speed. And I'm not going to use delta time this time. Because it's a physics-based thing. It doesn't quite make as much sense. It would be applying that much force per second. So, you know what, yes, let's still use it. You almost always want to use delta time, I suppose. So now if we hit play. And... whoa. This could be because I'm not applying a ton of force. Yep, that's exactly what's happening. You can see that it's moving very slowly, but not anything meaningful. So what if I jack this up to like 1,000? Okay, now you can see I'm starting to make it up, right? And things look a little smoother, but it's not quite as good. So, and I'm moving this in world space, right? I'm applying world forces. So, just adding forces, this is how you could make like a... what's the game where you have the little spaceship that you're moving it around? Or even asteroids you can make kind of like this. So, adding forces is one way to move with physics, but the other way to do it is just set velocities, okay? And this gives us more exact and precise controls, okay? So, for this, we still want to... we want to get our velocity, okay? And this is what offset's going to become. It's going to become our velocity, okay? It starts with 0, and then we set the x and y components, okay? And now we're going to say velocity times speed, okay? Multiply every component by our speed, okay? And delta time, so that our velocity is time safe. Actually, because this is physics, we still don't really want to do this. Okay, so because remember, velocity is going to be passing info to our physics simulation, not moving something this frame. So what we're saying is, tell physics this is how we want to move, and then physics will move us. It's a almost meaningless distinction functionally, but for our uses it's pretty important. So let's see, velocity times equals speed. That's right. So now we need to say rigid body dot velocity equals velocity. Okay. And what's actually happening here is sort of weird, okay? Because gravity is still happening. Gravity's sort of moving in a little bit each frame, but then we're setting velocity back to 0. So you can see now it's behaving a little bit more like this, but gravity's still happening, so our cube is kind of still falling slowly, and we can fix that. We can turn off gravity on our rigid body. Okay, and so now this is controlling very similarly to our old player controller.